Right. Also, in chapter 2, we did talk about a little bit about inequalities. So let's talk, well, first all about linear inequalities. 6x minus 7 is greater than or equal to 4x minus 2x plus 7. Okay. Good thing about this is, solving a linear equality is much like solving just a regular equation. Just want to get the x's on one side, right? Well, that would entail multiplying there by negative 2, so that's minus 2x minus 14. Combine the like terms. 4x minus 2x. Okay. So get the x terms to one side, constants on the other. Now, there is a time where we have to switch the symbol. Have I counted that yet? Not yet. I don't switch the symbol here unless I do what? Divide by a negative. Could multiply by a negative, but I've done neither of those. I've subtracted, I've added, but I haven't divided or multiplied both sides by a negative, so no, that doesn't come into play yet. This is just 4x greater than or equal to negative 7. Divide by 4. X is greater than negative 7/4. Now, okay. Remember that then means greater than, so it's everything greater than negative 7/4 on the number line. It's got the equal to part, so we use the little bracket. And then interval notation, well, that's where you use the comma and the parentheses or brackets and all that. In this case, it's left endpoint negative 7/4, the right endpoint is infinity. It goes on forever there. Yeah. This one, minus 3p plus 8 is greater than 11. Well, we'd add the 8. That doesn't change anything. Negative 3p is greater than 19. But we divide by negative 3 here. That changes it, doesn't it? That's where the rule says, flip it around. If it's greater than, change it to less than, and vice versa. Okay? So that's where the rule is. Now, we also had sometimes inequalities like this. negative 6 is less than or equal to, let's say 5y minus 9 is less than 20. What about that? Well, in that, 3-part, what's the story there? Get the y in the middle by itself. So I want to add the 9. Now, if I add 9 here, since it's got 3 parts, I've got to add it to all 3 parts. So I've got to add the 9 here and here as well in the middle. Negative 6 plus 9 is 3. That's less than or equal to 5y. It's less than 29. And it's 5 times y, so I need to get the 5 divided. So divide all 3 parts by 5, so I wind up with 3/5. It's less than or equal to y. It's less than 29/5. Okay, now, what does that mean number line wise? Well, just like it's showing there, The y is between 3/5 and 29/5, so that's the part of the number line we're talking about. It's everything between 3/5 and 29/5. I don't include the 29/5, so that's why I have the parentheses there, right? Bracket on the 3/5, because it is included. Okay. Also, we talked a little bit about absolute value and their equations and inequalities. On the equations, absolute value of 6x minus 11 equals 13. Yeah, the thing is, on the absolute value equation, you've got two answers there. And you find those two answers by doing two equations. We do just one by dropping out the absolute value, 6x minus 11 equals 13. The other one we do, though, is 6x minus 11, but not equal to 13, equal negative 13. Yeah. Those two equations will give you the two answers that we seek here. Add 11, 6x equals 24, divide by 6, x is 4. It's one of them. Here we add 11, 6x equals negative 2, divide by 6, x is, that reduces to be negative 1/3. Now, on one like this, make a pretty easy one. If you have the absolute value with a minus or a plus another number, the deal is to get the two correct answers, you're going to have to add the 9 first and then get absolute value of x minus 3 equals 21. Then do the 21 and negative 21. That'll give you the two. Yeah, if you go with 12 and negative 12, it turns out one of the answers isn't right. So add the 9 in this case, and then do the positive and negative thing. What would that be? 24 and negative 18. Okay. On the inequalities. Two scenarios. You got an absolute value greater than or an absolute value less than. For an absolute value greater than or equal to, yeah, it turns out one of them is, you're going to do two inequalities. You're going to do 3x plus 1 is greater than 5. But because it is an absolute value, you've got another one. You got the 3x plus 1, and you got the negative 5, just like on the equation. The only other thing is, what about the symbol? Change it also to less than. Yeah. So you do greater than 5, and you do less than negative 5 for a greater than inequality. For an absolute value greater than inequality. It's a mouthful. All right? And so what that gives you is 3x here is greater than 4, divided by 3, x is greater than 4/3. Over here we get minus 1, 3x is less than negative 6, divided by 3, x is less than negative 2. So what you get is greater than 4/3, so here's 4/3, everything greater, less than negative 2, yeah, you get two parts. This would be negative infinity to negative 2, and that one's 4/3 to infinity. That's what you'll always get for absolute value greater than inequality. Well, on a less than, 2b minus 9 is less than or equal to 25. Yeah, you got 2b minus 9 is less than or equal to 25. A little different on the less than, because remember that's the one it goes between two. It actually, yeah, you can actually do it all at once here if you put the minus 25 is less than or equal to 2b minus 9. Yeah, on the less than or equal to one, yeah, just make that three-part inequality. Put the minus 25 less than or equal to on the front there, and that'll be it. It's the one between. Less than or equal to is the one between. So that would be add 9, so that's negative 16 is less than or equal to 2b, less than or equal to 34, divide by 2. So negative 8 is less than or equal to b, is less than or equal to 17. Yeah, so it always goes between on the less than or equal to. The greater than or equal to, you got the two intervals on the ends. On the less than one, it's in between the two quantities there. Okay. A little bit there on chapter 2. Right.